Welcome to 10.6. In this section we're going to start talking about circles and arcs. Some definitions to start out with. We've got in a plane, a circle is a set of all points equidistant from a point called the center. So if we've got our circle here, there's a point in the middle called the center. And if we went to any of the sides of the circle, they would all be equally distant away from that center point. The next definition, a diameter, is a segment that contains the center of the circle and has both endpoints on the circle. So if we have a circle here with our center, that's a terribly drawn circle, I apologize, but the diameter goes through the center all the way across. A radius is a segment that has one endpoint and the center, so a radius is going to be half of the length of a diameter. A central angle is an angle whose vertex is in the center, so it'd be an angle like this right there. We can also have congruent circles, would have congruent radii, and the circumference is the measure of the outside edge of the circle. Sections of the circumference are called arcs, and there are three different types of arcs that we're going to be talking about in this section. The first type of arc we're going to be talking about is a minor arc. Okay, now minor arcs have degree measures less than 180 degrees, and we can name them by using two endpoints. So for examples, we could have AB and CB are minor arcs. Now the measure of a minor arc is the measure of the corresponding central angle. Okay, so in our example here, I could say that AB is a minor arc because that is less than 180 degrees. Or I could say that BC is a minor arc. Now if this is a right angle here, I could say that the measure of AB is also 90 degrees, so it's going to match the inside angle there. The next arc we're going to be talking about is a semicircle. Now a semicircle is exactly 180 degrees, so it's half of a circle. And to do that, we need to name it by using three endpoints. So for an example, we could have ABC as a semicircle, and the measure of a semicircle is always 180 degrees. So this would be an example of a semicircle, this ABC. The last type of arc we're going to be talking about is a major arc. Now major arcs are more than 180 degrees, and we're still going to name them using three endpoints. So for our example, it's going to be CAB is a major arc. And how we're going to find that measure is we're going to take 360 degrees minus whatever the minor arc that's left in the circle. So in our example here, if I go ACB, right here, that's a major arc. And to find that, if I know that this is a 90-degree angle, I can take 360 minus 90 and find that it's a 270-degree angle. So if we are given a picture here and we're asked to name the arcs, if I want to do the minor arcs of C, I have to label all of the arcs that are less than 180 degrees. Well, one of them here is AB. I could also have BE. I could have ED. And I could have DA. For these semicircles, so now we have to find the ones that go all halfway around the circle. So if I start at A, I could get halfway around the circle and I would stop at E. Now for semicircles, we have to label it with 3 points. So I could say A, B, E. What I could also do is I could go the other way around the circle. So if I went this way from A to E to get my semicircle, that would be a different semicircle. So I would label that as A, D, E. And so those are the two from A to E. I could also go from B to D. I could go to the right from B and have it be B, E, D. I could also go from the left and have it be B, A, D. So those are my 4 semicircles. When finding the major arcs, it might be easier to first label a minor arc so that we can find the major one that goes with it. So if I want to use this as my minor arc, this one between A and B, and I go all the way around this way, I can label that as BDA. If I want to use this as my minor arc, the angle between B and E, I could go all the way around this way and have the angle, or the arc, BAE. And I go all the way around, so if I have this as my minor, I can go this way and have it EAD. And finally, if I want this one, I can go all the way around and have it be AED. To find the measure of a minor arc, that's going to be equal to the measure of its corresponding central angle. So if I have my circle here and I've got an angle inside of here of 60 degrees, and I want to find the measure of this minor arc, it's also going to be 60 degrees. So these two are going to be the same number. To find the measure of a major arc, it's the measure of the related minor arc subtracted from 360. So if I now wanted the major arc that goes all the way around here, I would take 360 minus that minor arc of 60, and that would be a 300 degree angle, or a 300 degree arc. The measure of a semicircle is 180 degrees. Arc addition postulate, we can also add arcs together and to find the sum of them, just like we can add angles together. So for this example problem, we're going to be finding the measure of each arc. To start out with, we're going to find TU, which is right here. TU has a central angle of 60 degrees, so TU is also going to be a 60 degree arc. For the next one, SU. SU combines these two. Well, I've got my 60 degree central angle here and a 20 degree central angle there. So I take those two and I add them together, and my arc is 80 degrees. For RST, you'll notice that this is a semicircle. Well, semicircles always have 180 degree measures. And for the last one, RS, if I just want this, you'll notice again RST was 180 and ST was 20, so I can subtract those away to get my angle for RS, which is a 160 degree arc. Our next definition is the circumference of a circle is the distance all the way around. We have a theorem for that, 10(9). To find the circumference of a circle, we take the diameter times pi. Now remember, the diameter is the length all the way across the circle. Okay, so that's this formula right here. Or we can write it in terms of the radius. Radius is halfway around, or halfway across the circle. We can find the circumference by doing 2 pi times radius. So probably a good idea to write down both of these formulas to go with circumference of a circle so you remember it for later on. The next thing we're going to be talking about is arc length. So now we're not going to figure out the degree of the arc, but we want to actually figure out how far the arc goes, so the distance between A and B. And to do that, we need to know our radius r. So first things first, write down these two formulas, because those are going to be very important. So how we're going to use this is we have to know the measure of the arc on the outside. And what we're going to do with that is we're going to divide it by 360, and then we're going to multiply it by our circumference formula, either the 2 pi r that we had before or the pi times diameter. Either one of those would work just fine. But again, arc measure divided by 360 times the circumference of our circle. So if I'm looking for the arc length CD here, CD, I know the measure. I know that this is a 90 degree arc because the central angle was 90 degrees. I also know that the diameter is 9 centimeters. So to find the actual arc length, I would take the degree over 360 times pi times my diameter. So I've got 90 over 360 times essentially 9 pi. 90 over 360 simplifies down to a fourth. And then if I type that into my calculator and I round it, I will get 7.1 centimeters for my arc length. So next I want you to figure out the lengths of SR and the length of STR. And then when you have that done, you can press play and check your work. So for length SR, we've got the arc is 100 degrees, so I take 100 over 360 times 2 times pi times my radius of 4. And if I type that in, I get that it is about 6.98 feet in length. For STR, if SR was 100 degrees, STR would be 360 minus that, which would give me 260. So I put 260 over 360 times 2 times pi times 4, giving me about 18.15 feet.